Here's a table that I want you to write down. And we're going to find the rule, which is interesting because usually rules are given to you, but we're going to find the rule. Right. Now let's pretend that we didn't know the rule for this one, okay? I think some of you might already know it, but let's pretend we didn't. How could we do this? How could we, and the question is often asked you to find a rule or find the linear relationship between these, right? So that's the question. Find a linear relationship between these from a table, okay? So the way I want to do it is, I'm actually going to get some colors out. And the first thing we want to know is, on the x there, are they increasing by 1? Is each of these increasing by 1? If they are, then we can use this method, okay? So are they increasing by 1 each time? All right, if that's the case, then that's good. We can use this method. That's the first thing. Is everything increasing by 1? So top value is increasing by 1 after each one. The next thing to look at is, what are the bottom values increasing by? 2. Yeah. Can you see that? Can you write that down for me? And I'm using colors because I think it makes it very clear what's going on. Increasing all of these by 2 each time. So the bottom values are plus 2. And the last thing that we want to work out is, okay, when x is equal to 0, what is y? So when x is equal to 0, what does y equal to here? Well, y is equal to 1. You see that? So how do we put all of this together? Why is this information useful? Well, because it's all leading up to this point where I want some kind of equation. I want y is equal to something related to x. Okay? And so I start off by saying, well, y is equal to. Every time we're increasing this by 2, you can think about that as 2x, which was the bottom value. So basically, the number that we're increasing by is going to be the coefficient here, the number in front of the x there. Okay? But we sometimes have a number at the end. Can you see that? We sometimes have a number at the end. And that number at the end is going to be what the value of y is when x is equal to 0. Right? So what was the number? It was just 1. So let's see how this all fits together. When x is equal to 0, basically this whole thing goes away, right? Because when there's a number and a letter next to each other, it means multiplication. Yeah. So that goes away. So y is equal to 1. Can you guys see that? So when x equals 0, y equals 1, that's our starting point. And then each time I increase the value of x by 1, how much is y increasing by? Well, it's increasing by 2. So that's why I put a 2 in the front. And that's how you can create your rule. Because now when we check this in, x equals to 0, y equals to 1. When x is equal to 1, well, y, that becomes a 1. So we get 2 plus 1, that's just 3. And you can check that so forth. 2 times 2 plus 1 is 5. That's how we can develop our rule for a linear relationship. Yeah, let's write that down for me. I'll give you another one to try. Questions about that?
I don't know how you. I'm about to say this, but I don't know how you do it.
Yeah. Okay, so I've been explaining it step by step with these colors and stuff like that as well. Let me try another example to make it a bit clearer. If this did this really make sense or a bit confusing? Yeah.
Just a long description.
It is a long way of doing it, and the only reason I'm showing this way is because I think it's hard sometimes to just try and guess and check in your head what it's going to be. Let me give you another one just to show you how this works again. Right? Here's another example. If you think you can do it in your head, that's fine. But this is just one way of doing it, right?
I just did it in my head.
Yeah, that's good, didn't you? Yeah. You did it in your head as well, Jesse?
No, I was just going to say, where did you get the 1 from?
Where did the 1 come from? The 1 came from when x is equal to 0, what is the y equal to? So when x is 0 here, what's the y I get?
What about that one there that
Yep.
you're covering up? Does it have to be what it equals to when it's 0?
Sorry, go again. Yep.
Because the other one there,
This one here?
it doesn't have 0.
Ah, okay. Well, then that makes it tricky then, right? Well, actually, when x... Yeah, that's interesting. That one...
4 by 3 and then you get 0. Yeah.
Yeah.
when x is equal to 0 here, y equals to... Yeah. Okay. So this... Sometimes this doesn't work. So yeah, how do I explain this without confusing you? Basically, for this one, right, because we're actually using physical matchsticks, it doesn't actually make sense to have like 0 squares and match 6, right? So I guess you could say it doesn't work for values where x is less than 1, right? Obviously, because like x, right, you can put a negative number into this and you'll get some number out, right? You could put in -1 and you would get -1, okay? But if you put -1 into this, like it doesn't make sense to have -1 squares. Like what does that even mean, right? That's the kind of problem with this analytic notation. It's only working for values bigger than 1, yeah. But this one over here, right? Let's look at this one. Let's try this way again. If it works for you, that's great. If you can do it, all of them in your head, that's fine too. Okay, can we try this one out together? Yeah. So are these first ones increasing by 1 each time on the top? Yeah. Good. Then we can do this. Okay. And what about the ones on the bottom? What are they increasing by each time? 4.
So could we just do a pink arrow and then do equals +4?
Yeah, I could do that. That's fine too. Okay, and when x is equal to 0, what's my y value? So when x is equal to 0, y is equal to 3. So let's put that all together now. I've got y is equal to. So what number goes with the x? Well, the number that's on the bottom here that's increasing by each time. So that's 4x. And yeah, when x is equal to 0, y is equal to 3, so I get +3. Hands up if you got that one. Keep your hand up if you just did it in your head. Interesting. Okay, so not too many of you. This method here, right? This method is a way that takes a little bit longer. But I think kind of like when you're solving equations and stuff like that, it's a foolproof way of doing it because you can do it for anyone, yeah? Go, Brooklyn.
So like this bottom one allowed you to help.
Yeah.
You not do it for that because it doesn't have a 0.
Ah, does it not have a 0?
Well, it does, but it's like further in.
Well, why don't we try it for the one on the bottom, right? So when x is equal to 0, y is equal to 3, right? And what's the numbers increasing by each time on the bottom? 4. So that one would be y equals to 4x plus 3. Is that the rule that we got? Is that yeah. So does that make sense for them? You can always use it if you have the information required. Yeah. Let me give you another one, and this one's a little bit different. So look at this one carefully. Okay.
Sorry, do you just want to tell me my answer?
Oh yeah. Just really briefly, how you got it?
So I got the bottom was +3.
Yeah.
So you do 3x, and then that other one is 2. So you do +2.
Yeah, see how quick it is once you realize this pattern, right? Basically you say y is equal to, okay, whatever this number is, that's the coefficient of x. And then whatever x is equal to when, so whatever y is equal to when x is equal to 0, that's our number at the end, or we call that a constant sometimes, yeah. Isaac, what was different about, all good? Bless you. Isaac, what was different about part 4? Yeah, is there anything different about it? It's got minus numbers. Anything else? Maybe?
The 0 equals -2.
Yep, that's true, that's true. Look at the numbers on the bottom though. What's the pattern there? These ones here, year 8. These ones here, they are increasing by 1. But what's happening with these ones? They're increasing by 2. Okay, so we have some negatives, but we're still increasing them by 2. So we can still apply this rule, right? I say that y is equal to. I've got, yeah, I heard it. Someone said it. 2x minus 2. So sometimes this guy can be a minus, and that's okay. That can be a minus, okay? All right. This one, though, is the one I was actually thinking of. This one is different. Even though it's increasing by 1 each time, what's happening on the bottom? We're actually decreasing. And this is why it gets tricky to do in your head, because when it starts decreasing, like, I don't really know what the pattern's going on. It's a little bit tricky. But if you use this method, you just have to identify what it's changing by on the bottom each time. It's not increasing now, it's decreasing. How do I represent that? I can represent that with a -4. Yeah. So let's still put that all together. What's my rule going to be? Well, I'll always start with y is equal to. And I know that this is going to be my coefficient of x, so that's -4x this time. So I'm actually doing -4x. And what's the number by itself? Well, when x is equal to 0, y is equal to -4. Okay. So, and you can test those points out and see that they do work. Next lesson, I didn't quite get up to it. I'm going to talk about how this relates to these graphs.